This is the EdExcel A-Level Maths Paper 2 covering the pure mathematics content, and this is from the 2022 series. Question number 1. Figure 1 shows a sketch of the graph with equation y equals the mod of 3 subtract 2x, and what we have to do is solve the equation the mod of 3 subtract 2x equals 7 plus x. Our first step would be to replace the modulus signs with plus minus. So we have plus minus 3 subtract 2x, and this is equal to 7 plus x. Let's deal with the positive. We have 3 subtract 2x equals 7 plus x. 3x is equal to negative 4, in which case we can see x is equal to negative 4 over 3. This is one solution. And if we deal with the negative, well, we have negative 3 subtract 2x equals 7 plus x. Multiplying the negative 1 into the bracket, we would end up with 2x subtract 3 equals 7 plus x, and simplifying and solving, we can then see x is equal to 10. So we have a solution x equals negative 4 over 3 and x equals 10. Question number 2. For part A, we have to sketch the curve with equation y equals 4 to the power of x, stating any points of intersection with the coordinate axis. Here is the graph of y equals 4 to the power of x. It crosses the y-axis at the point 1, and it has an asymptote on the x-axis. For part B of the question, we have to solve 4 to the power of x equals 100, giving your answer to 2 decimal places. Well, for part B, we have the equation 4 to the power of x equals 100, and if we were to find out what x is equal to log base 4 of 100, and if we find out what the solution to this is, we have log base 4 of 100, and that to 2 decimal places is equal to 3.32. Question number 3. A sequence of terms a1, a2, a3, etc. is defined by a1 equals 3 and an plus 1 equals 8 subtract an. For part A, for the first part, we have to show that this sequence is periodic. So for the first part, what we know so far is a1 is equal to 3. And if we were to use the formula for the sequence, a2 then will equal 8 subtract a1. So we have 8 subtract 3 which is equal to 5. A3, that will equal 8 subtract A2. So we have 8 subtract 5, which is equal to 3. And A4 is equal to 8 subtract A3. So we have 8 subtract 3, which is equal to 5. Now, what do we notice? Well, hopefully we notice A1 equals A3, and in general, A odd is equal to 3, and A2 equals A4, and in general, A even equals 5. We have A1 equaling A3, and in general, A odd equaling 3, and A2 equaling A4, and in general, A even equaling 5. We see the formula for generating the sequence is unchanged, so the sequence will repeat itself, and so the sequence is periodic. For the next part, we have to state the order of this periodic sequence. Well, if A1 equals 3 and A3 equals 3 and so on and so forth, and A2 equals 5 and A4 equals 5 and so on and so forth, what we can see then is every 2 terms the sequence is repeating, and so the order is 2. Now for part B, we have to find the value of the sum of an from n equals 1 to n equals 85. So the sum of an from n equals 1 to n equals 85, that's equal to A1 plus A2 plus A3 plus A4, and then we can continue on with our sequence, and for the final couple of terms we would have A83 plus A84 plus A85. So we know that A1 is equal to 3, A2 is equal to 5, A3 is equal to 3, A4 is equal to 5, and then we can add on a couple of more terms, and then for the final couple of terms, A83, well, because 83 is odd, A83 will equal 3, A84 will equal 5, and A85 will equal 3. Now, from A1 to A84, the sequence has been repeated 42 times. So we have 42 times by A odd plus A even. And then we have the 85th term, A85, which is 3. And so we have 42 multiplied by A odd, which is 3, plus A even, which is 5, plus an extra 3. And if we were to work this out, 42 multiplied by 3 plus 5 plus an extra 3, it turns out we get 339. And so therefore, the sum from n equals 1 to 85 of an is equal to 339. Question number 4. We are given that y is equal to 2x squared, and we have to use differentiation from first principles to show that dy over dx equals 4x. Here is the formula for differentiation from first principles. F dash of x is equal to the limit as h tends towards 0 of f of x plus h subtract f of x over h. And so the way to approach this question is to begin by letting f of x equal 2x squared. And so now what we need to find is f of x plus h. We replace the x with x plus h. So we have 2 multiplied by x plus h squared. So we have 2 multiplied by x squared plus 2xh plus h squared. And what you'd find is this is equal to 2x squared plus 4xh plus 2h squared. And so therefore f dash of x, that's equal to the limit as h tends towards 0 of f of x plus h subtract f of x divided by h. And so evaluating this, we have the limit as h tends towards 0 of f of x plus h, which is 2x squared plus 4xh plus 2h squared subtract f of x, which is 2x squared. And then we divide this by h. So, evaluating this, we have the limit as h tends towards 0 of, well, we have the 2x squared and the negative 2x squared simplifying to 0. And then we have 4xh over h, which is just 4x. And we also have 2h squared over h, which is just 2h. And then as h tends towards 0, 2h will also tend towards 0, leaving us with 4x. And so therefore, f dash of x which is the same as dy over dx, that's equal to 4x. Question number 5. The table below shows corresponding values of x and y. For y equals log base 3 of 2x, the values of y are given to 2 decimal places as appropriate. We have x values and y values, and for part A, using the trapezium rule, with all the values of y in the table, we have to find an estimate for the integral of log base 3 of 2x with respect to x with limits 3 to 9. So we need to use the trapezium rule, and if we go to the formula book, here is the formula for the trapezium rule. Now if we look at our table, we can first of all determine the value of h. If we take a look at the x values from 3 to 4.5, we add 1.5. From 4.5 to 6, we add 1.5. And from 6 to 7.5, again, we add 1.5. And 7.5 to 9, we add 1.5. And so therefore, we can see then, h is equal to 1.5. And now, if we go back to our table, we can label these y values y0, y1, y2, y3, and y4. And so therefore, the integral is approximately equal to 1/2 multiplied by h multiplied by, then in brackets, well, we have here y0 plus 2 multiplied by y1 plus y2 plus y3, and then close bracket, plus y4. And so now we can estimate the integral as required. So the integral between 3 and 9 of log base 3 of 2x with respect to x, that's approximately, well, we have 1/2 multiplied by h, which is 1.5, multiplied by well, here we have y0, which is 1.63, plus 2 lots of y1, which is 2, plus y2, which is 2.26, plus y3, which is 2.46, plus y4, which is 2.63. And then we close the brackets. So let's work this out. we have 1/2 multiplied by 1.5 multiplied by, and then in brackets, 1.63 plus 2 multiplied by 2 plus 2.26 plus 2.46 plus 2.63, and it turns out we get a value of 13.275. And now for part B, using your answer to part A and making your method clear, for the first part we have to find an estimate for the integral of log base 3 of 2x to the 10 with respect to x between 3 and 9. So, for the first part of part B, we've got the integral between 3 and 9 of log base 3 of 2x to the 10 with respect to x. And what this is equivalent to, using the power law of logs, is the integral from 3 to 9 of log base 3 of (2x) multiplied by 10. I'm integrating with respect to x. And so what we need to do then is multiply the value we found in part A by 10. So we have 10 multiplied by 3.275. So our integral is approximately equal to 132.75. And then we have the integral of log base 3 of 18x with respect to x between 3 and 9. So for the next part, we have the integral between 3 and 9 of log base 3 of 18x with respect to x. And what this is equivalent to is the integral from 3 to 9 of log base 3 of 2x multiplied by 9. We recognize here we have the 18x, which has been rewritten as 2x multiplied by 9. And now, using the addition law of logs, we can then say that this integral is equivalent to log base 3 of 2x plus log base 3 of 9. So, recognizing that log base 3 of 9 is 2, what this is all equivalent to then is the integral from 3 to 9 of log base 3 of 2x plus 2 with respect to x. And so we can split this up. We've got the integral from 3 to 9 of log base 3 of 2x with respect to x plus the integral from 3 to 9 of 2 with respect to x. Now, we have already worked out what the integral of log base 3 of 2x with respect to x between 3 and 9 is. That is approximately 13.275. And if I integrate 2 with respect to x between 3 and 9, well, integrating 2 with respect to x, we end up with 2x. And we are evaluating this between 3 and 9. And so, we have 13.275 plus, well, for our upper limit, we have 2 multiplied by 9, and for our lower limit, we have 2 multiplied by 3. So we have 13.275 plus, well, here I've got 18 minus 6, which is 12. And so therefore, we have 25.275. Question number 6. Figure 2 shows a sketch of part of the curve with equation y equals f of x, where f of x is equal to 8 multiplied by the sine of 1/2 x, subtract 3x plus 9, where x is greater than 0, and x is measured in radians. We've got the point P, which we see in figure 2, and this point is a local maximum point on the curve. Using calculus and the sketch in figure 2, for part A we have to find the x coordinate of P, giving an answer to 3 significant figures. Well, if we have a local maximum, that suggests to us we need to first of all differentiate to find f dash of x, and then set f dash of x equal to 0 because we have a local maximum point. We've got a stationary point. And so for part A, we have f of x, which is equal to 8 multiplied by the sine of 1/2 x, subtract 3x plus 9. And so therefore, f dash of x, well, if I differentiate sine, I get cos, and then multiplying the 8 by the differential of 1/2 x, so multiplying 8 by 4, rather 8 by 1/2, we have 4, multiplied by the cosine of 1/2 x, and then we subtract 3. And so what we need to do now is set f dash of x equal to 0. So we have 4 times by the cosine of 1/2 x, subtract 3 equals 0. And rearranging, we have the cosine of 1/2 x equals 3/4, and what we need to do is now find x. So we have 1/2 x equals, now if I work out the inverse cosine of 3/4, in radians, we end up with 0.722, etc. We'll store this into A. To find the next value, we need to do 2 pi, subtract what we just found here, which is 5.560, etc. We'll store this into B. And because cosine repeats every 2 pi, we have our original value 0.722, etc. and then we need to add on 2 pi to this. And it turns out we get 7.005, etc. And the reason we need to find this third value, using the curve, we have a stationary point here. So we have f dash of x equaling 0 here. We have another stationary point here. So we have f dash of x equaling 0 here. And we have another stationary point here, where P is. And so what we want is the third value of x. So, with each of our values, if we multiply those by 2, we have x equals, well here, we have 2 multiplied by a, which is 1.445, etc. Then we have 2 times by b, which is 11.120, etc. And then we have 2 times by c, which is 14.011, etc. So, this 1.445, etc. would correspond to the first stationary point we see. The 11.120, etc. would correspond to the next stationary point, and the 14.011, etc. would correspond to the third stationary point. And so what we want is the 14.011 for the x-coordinate of P. So the x-coordinate of P to 3 significant figures is 14.0. Now, the curve crosses the x-axis at the point x equals alpha, and that's what we see in figure 2 here. We are given that to 3 decimal places, f of 4 is 4.274 and f of 5 is minus 1.212. We have to explain why alpha must lie in the interval 4 to 5. Well, for part B of the question, we know that f of 4 is equal to 4.274, and this value is greater than 0. And what we also know is f of 5 equals minus 1.212, and this value is less than 0. What we can also say then, because we have a change of sign, we are going from something positive to something negative, and we see that f of x is continuous in the interval 4 to 5, meaning, if we go back to our diagram, there's no breaks in the curve between 4 and 5. Because of those two, we can therefore conclude we have a root alpha in between 4 and 5. Now for part C, taking x0 equals 5 as a first approximation to alpha, we have to apply the Newton-Raphson method once to f of x to obtain a second approximation to alpha. Show your method and give your answer to 3 significant figures. Well, here is the formula for the Newton-Raphson method when we are solving f of x equal to 0. xn plus 1 equals xn subtract f of xn over f dash of xn. And so, for part C, if we are solving f of x equals 0, using the Newton-Raphson method, we have xn plus 1 equals xn subtract, well, we have f of x, which is equal to 8 multiplied by the sine of 1/2 xn, subtract 3 xn plus 9, and then we divide this by f dash of xn, which, if you recall, we worked out previously. So f dash of xn will be 4 times by the cosine of 1/2 xn subtract 3. Now, we are given that x0 is equal to 5, and what we can do is find out what x1 is. We were told to apply the Newton-Raphson method once, so that's equal to x0 subtract 8 multiplied by the sine of 1/2 x0 subtract 3 times by x0 plus 9 divided by 4 times by the cosine of 1/2 x0 subtract 3. So if we work this out, we have 5 subtract 8 times by the sine of 1/2 multiplied by 5 subtract 3 multiplied by the 5 plus 9, and then we're going to divide this by 4 times by the cosine of 1/2 multiplied by 5 subtract 3. So if we work out this, then using our calculator, ensuring we are in radians because we have differentiated with trig functions, well, if I type in 5 into my calculator, then replacing x0 with the answer function, we have answer minus 8 times by the sine of 1/2 answer subtract 3 times by answer plus 9 divided by 4 times by the cosine of 1/2 answer subtract 3. And it turns out we have 4.80462, etc. which means that alpha is equal, well, rather, a second approximation to alpha is 4.80 given to 3 significant figures. Question number 7. For part A, we have defined the first 4 terms in ascending powers of x of the binomial expansion of the square root of 4 minus 9x, writing each term in simplest form. For part A, we need to use the binomial expansion. Now, if we go to the formula book here, we see the formula for a binomial series. We have 1 plus x raised to the n, shown by this result here, where n is a real number. So, if we have 4 minus 9x and then square rooted, what we want to do is rewrite this result so that we have a 1 plus a multiple of x raised to the n. Now, before we do anything else, we can recognize that square rooting something is the same as raising something to the power of 1/2. So we have 4 subtract 9x raised to the power of 1/2. Now, if we factorize out a 4, then we have 4 multiplied by 1 minus 9x over 4, and then all of this is being raised to the power of 1/2. And using the laws of indices, we can see that this is the same as 4 to the power of 1/2 multiplied by 1 minus 9x over 4 raised to the power of 1/2. So 4 to the power of 1/2 is the same as 2. So we have 2 multiplied by 1 minus 9x over 4 to the power of 1/2. And now we need to find the expansion of 1 minus 9x over 4 to the 1/2, and we can do that using this formula here. So if we keep the 2 on the outside, we have 1, and then the next term, we have 1/2 being multiplied by minus 9 over 4x, and then we divide this by 1 factorial. For the next term, we've got 1/2 multiplied by 1/2 minus 1 multiplied by minus 9 over 4x squared, all divided by 2 factorial. And then for the next term, we have 1/2 multiplied by 1/2 minus 1 multiplied by 1/2 minus 2 multiplied by minus 9 over 4x cubed. and then we divide this by 3 factorial, and then we add on extra terms. So now, if we continue with this, we have 2 multiplied by, well, here I've got 1, and then here I've got a half times by minus 9 over 4, so that will be minus 9x over 8. And then for the next term, we have a half multiplied by a half minus 1 multiplied by minus 9 over 4 squared over 2 factorial. So that's minus 81 x squared over 128. And then for the next one, we have a half times a half minus 1 times by a half minus 2 multiplied by minus 9 over 4 x cubed over 3 factorial. So that's minus 729 x cubed divided by 1024. And then we have other terms which we can consider. So, multiplying what's inside the bracket by 2, we end up with 2 minus 9x over 4 minus 81 x squared over 64 minus 729 x cubed over, well, if I multiply this by 2, we have minus 729 x cubed over 512. And then we've got other terms as well. And this expansion will be valid for the mod of x being less than 4 over 9. Now for part B, a student uses this expansion with x equals 1/9 to find an approximation for root 3. Using the answer to part A and without doing any calculations, we have to state whether this approximation will be an overestimate or an underestimate of root 3, giving a brief reason for your answer. Well, it will be an overestimate because the terms that have been omitted will all be negative. Question number 8. Figure 3 shows a sketch of part of a curve with equation y equals x minus 2 multiplied by x minus 4 over 4 multiplied by the square root of x, where x is greater than 0. So that's what we see here. The region R, which we see in figure 3, is bounded by a curve and the x-axis. We have to find the exact area of R, writing your answer in the form a root 2 plus b, where a and b are constants to be found. First of all, we can find out where the curve intersects the x-axis, and we can do this by setting y equal to 0. So with y equaling 0, we have x minus 2 multiplied by x minus 4 divided by 4x to the, 4 times by the square root of x. This is all equal to 0. And that means then that x minus 2 multiplied by x minus 4 equals 0, in which case x is equal to 2 or x is equal to 4. So if we go back to our diagram, we can add on these points as coordinates. We have 2, 0, and we also have 4, 0. So now, to find the area of R, we can integrate the curve with these limits. Now, for us to integrate, we need to write this result in an integrable form. So far, we know that y is equal to x minus 2 multiplied by x minus 4 divided by the 4 times the square root of x. Now, if we expand the brackets on the top, x times x is x squared, then we have minus 4x minus 2x, so that's minus 6x, and then minus 2 times by minus 4 is positive 8. And then on the bottom, we can rewrite the 4 times the square root of x as 4 multiplied by x to the power of 1/2. So now each term on the numerator can be divided by 4x to the half. So we have x squared divided by 4x to the half, subtract 6x over 4x to the 1/2 plus 8 over 4x to the half. And if we were to simplify this even further, we have y equals, well, x to the half divided by 4x to the 1/2, subtracting the powers, we end up with x to the power of 1/2 divided by 4, rather x to the power of 3 over 2 over 4. 2 take away a half is 3 over 2. And then we have 6 over 4, which is 3 over 2. And then x to the 1 divided by x to the half, that will be x to the half. And then 8 over 4 is 2. And then we have x to the power of negative 1/2. So, if we now integrate, well, integrating between 2 and 4, what equation y is, which is given by this result here, with respect to x, this will be equivalent to integrating between 2 and 4, the result we see here. x to the 3 over 2 over 4 subtract 3x to the half over 2 plus 2x to the negative 1 half with respect to x. And so if we work this out, well, integrating x to the 3 over 2 over 4, well, if I have 3 over 2, and if I add 1 to the power and then divide by the new power, so I've got 1/4 divided by this, integrating x to the 3 over 2 over 4, we end up with then x to the 5 over 2 over 10, and then if I add 1 to the power, I get x to the power of 3 over 2, and then if I divide by the new power, so I've got 3 over 2 multiplied by 2/3, which is just 1, and then if I add 1 to the power, I get x to the power of 1/2, and if I divide by the new power, 2 divided by 1/2 is 4. And I'm integrating between 2 and 4. So now we can evaluate this. So if I substitute in for my upper limit, we have 4 to the 5 over 2 over 10, subtract 4 to the 3 over 2, plus 4 multiplied by 4 to the 1/2, so that's what we get for our upper limit. And for our lower limit, we have 2 to the 5 over 2 over 10, subtract 2 to the 3 over 2, plus 4 multiplied by 2 to the 1/2. So this is what we get for our lower limit. Question number 9. Figure 4 shows a sketch of a Ferris wheel. The height above the ground, h meters, of a passenger on the Ferris wheel t seconds after the wheel starts turning is modelled by the equation h equals the mod of a sine of bt plus alpha degrees, where a, b and alpha are constants. Figure 5 shows a sketch of the graph of h against t for one revolution of the wheel, given that the maximum height of the passenger above the ground is 50 meters, the passenger is 1 meter above the ground when the wheel starts turning, and the wheel takes 720 seconds to complete one revolution. We have to find for part A a complete equation for the model giving the exact value of A, the exact value of B and the value of alpha to 3 significant figures. Now, one way to think about this is to think about the graph of sine x. We know it's got a maximum at 1. Now, what we want is for our maximum height to be at 50 instead. And so, for us to get a maximum height of 50, I would have to multiply by 50. And so you can see here, sine x, if I multiply that by 50, that gives me a maximum height of 50. Now it doesn't matter what's happening inside the bracket here. If I have bx plus a, all the a and b is doing is shifting the graph to the left or to the right, and the b is stretching it as necessary. And so what we have to do is multiply by 50. And so by inspection, for part A, we can see A is equal to 50. So that's by inspection. Now, we know that initially it's 1 meter above the ground. So, if that's the case, when t equals 0, h is equal to 1. Now, if we use our equation, we've got the absolute value of a, which is 50, times by the sine of b times by 0, because t is 0, plus alpha degrees. This is equal to 1. And so what we have then is 1 equals 50 sine alpha. And what we need to do is find out what alpha is then. So sine alpha is 1 over 50, and therefore the inverse sine of 1 over 50, that's equal to 1.15 to 3 significant figures. So alpha then is equal to 1.15 degrees given to 3 significant figures. And now we need to determine the value of b. So we know that a in our case is equal to the inverse sine of 1 over 50 which is 1.145, etc. And we know as well if we remove the a for a moment and set b equal to 1, we know the regular graph of sine crosses at 180. Now what we want is the absolute value of this graph here. It crosses at 180, 0. Now we know from the question the wheel takes 720 seconds to complete 1 revolution. So what can we say then? Well, we know that the period of sine x, the absolute value of this, is 180 degrees. And the period of h will be 720 because it takes 720 seconds to complete 1 revolution. So the period of h of t that will be 720 degrees. So what are we saying here? Well, instead of us having a 180 degrees, essentially here, what we want this to say is instead 720. And so from 180 degrees to 720 degrees, what we want is a stretch with scale factor 4 in the x direction. So if I stretch by scale factor 4 in the x direction, that means b then must equal 1/4, because that will ensure that we have 720, and if I include the a with it, we still have this period of 720 degrees from here to here. We still have from minus 4.5 etc. to 715.4 etc. That is 720 degrees. So we want to stretch scale factor 4 in the x direction, which implies b equals 1/4. So with b equaling 1/4, we can therefore conclude that h is equal to 50 multiplied by the sine of 1/4 t plus 1.15 degrees. So that is what h is equal to, and this is given to 3 significant figures. Now for part B, we have to explain why an equation of the form h equals the mod of a sine of bt plus alpha plus d, where d is a positive constant, would be a more appropriate model. Well, although the existing model has the passenger starting 1 meter above the ground, there is a point in the cycle where the passenger is 0 meters above the ground, and that's what we see at the point over here. And so in reality, the passenger would never be on the ground during the ride. So let's think about this. We are 0 meters above the ground, and that is over here. And so the value of d would ensure the passenger is not on the ground during the ride, and that is because to go from h equals the absolute value of 50, well, the absolute value of a sine of bt plus alpha degrees to the graph of h equals the absolute value of a times by the sine of bt plus alpha degrees plus d. This over here is a translation by vector 0 d. We're moving the graph d units up essentially. Question number 10. The function f is defined by f of x equals 8x plus 5 over 2x plus 3, where x is greater than negative 3 over 2. For part A, we have defined the inverse of f at x equals 3 over 2. So, For part A of the question, we are given that f of x is equal to 8x plus 5 divided by 2x plus 3, where x is greater than negative 3 over 2. And for us to find the inverse function, the first thing we need to do is replace f of x with y. And doing so, we have y equals 8x plus 5 divided by 2x plus 3. And if I multiply through by 2x plus 3, we have y multiplied by 2x plus 3 equals 8x plus 5. So we have 2xy plus 3y equals 8x plus 5. So we have 2xy plus 3y. Well, if I gather everything over on one side that involves an x, everything that doesn't involve an x on the other side, we have 2xy subtract 8x equals 5 minus 3y. And on the left, if I factorize out an x, we have x multiplied by 2y minus 8 equals 5 minus 3y. And if I divide through by 2y minus 8, we can then see that x is equal to 5 minus 3y over 2y minus 8. And what we want is to now swap the x and y. So swapping the x and y, we have y equals 5 subtract 3x divided by 2x minus 8. And now if we replace y with the inverse function, the inverse function of f is equal to 5 minus 3x over 2x minus 8. Now what we need to do is find out what the inverse function is at 3 over 2. So we have 5 subtract 3 multiplied by 3 over 2 divided by 2 multiplied by 3 over 2 minus 8. And if we work out what this is, the inverse function when x equals 3 over 2, that's equal to negative 1/10, which is our solution. Now for part B, we have to show that f of x is equal to a plus b over 2x plus 3, where a and b are constants to be found. So for part B, we have 8x plus 5 divided by 2x plus 3. This will be equivalent to a plus b over 2x plus 3. And what we need to do is find out the values of a and b. And we can do this by multiplying through by 2x plus 3. So we have 8x plus 3 being equivalent to a multiplied by 2x plus 3 plus b. We can find the values of a and b by comparing coefficients. If we take a look at the x terms, we have 8 of them on the left hand side, and on the right hand side we have 2a of them. A is equal to 4. And if I compare the number terms, we have 3 equals 3a plus b. Now I know that a is 4, so I'll have 3 equals 3 multiplied by 4 plus b. 3 equals 12 plus b. Rather, here we have 8x plus 5. So we have 5 equals 3a plus b. So 5 equals 3 times 4 plus b. So 5 equals 12 plus b. So b is negative 7. And now, knowing that a is 4 and b is 7, we can therefore conclude f of x is equal to 4 subtract 7 over 2x plus 3. And now, for part C of the question, the function g is defined by g of x equals 16 minus x squared, where x is in between 0 and 4. We have to state the range of the inverse of g. For part C of the question, we know that g is equal to 16 minus x squared, where x is in between 0 and 4. Now the range of the inverse function is the domain of the function. So we still have our limits between 0 and 4, but instead of us having an x, we would have the inverse of g. So here is the range. The range is given by 0, which is less than or equal to the inverse of g, which is less than or equal to 4. So now we need to find the range of f of the inverse of g. Well, here we've got the graph of g. Between 0 and 4, this is plotted. Now, for its inverse, which is shown in green here, that goes from 0 to 4. Here is the graph of f. We see it's defined for values of x being greater than negative 3 over 2. And what we need to do is put the inverse of g into f, and that will leave something looking like this. Now what we need to do is find the range of this graph over here. Now to do that, if we have f of the inverse of g, which is what we need to find the range of, we first of all need to do the inverse of g and then put that into f. Now we know that for the inverse of g, the values that would come out of the inverse of g will be in between 0 and 4. And so what we need to do then is substitute in these into f. And this will give the range of the combined function. So, if we work out what f of 0 is, so this 0 comes from here, I substitute in 0 into f, so we have 8 multiplied by 0 plus 5 divided by 2 times by 0 plus 3. So it turns out we get 5 over 3. And then we can find out what f of 4 is. So for here, we substitute in 4. So we have 8 multiplied by 4 plus 5 divided by 2 times by 4 plus 3. And so what we've done here is substitute in 4. And if I work this out, I get 37 over 11. So when we work out f of the inverse of g, we work out what the inverse of g is at a particular value, and then we substitute that into f. Now, when I work out the inverse of g, I know that my values will be in between 0 and 4. So then, between 0 and 4, I can substitute those values into f, and that will tell me the range of f of the inverse of g. So therefore, we have 5 over 3 as our lower limit, 37 over 11 for our upper limit. This is the required range of f of the inverse of g. Question number 11. Prove using algebra that n multiplied by n squared plus 5 is even for all natural numbers of n. Well, here, if n is a natural number, it can either be odd or even, so we need to consider those cases separately. So, let's consider the case where n is even. So if n is even, then what we can say here then n would equal 2m, where n and m belong to a set of positive integers. And if that's the case, if we have n multiplied by n squared plus 5, we replace the n with 2m. So we have 2m multiplied by 2m squared plus 5. So if I work this out, I have 2m multiplied by 4m squared plus 5, which is the same as 2 multiplied by 4m cubed plus 5m. And we want to show that this result is even, and this result is even because it's got 2 as the factor. So this 2 as a factor suggests to us that n multiplied by n squared plus 5 is even. We've also got the other case where n is odd. And if n is odd, then we can say from here n is equal to 2m plus 1, when again n and m belong to a set of positive integers. And so in this case, if we work out n multiplied by n squared plus 5, we have 2m plus 1 multiplied by 2m plus 1 squared plus 5. So we have 2m plus 1 multiplied by 4m squared plus 4m plus 1 plus another 5. So we have 2m plus 1 multiplied by 4m squared plus 6m plus 6, rather plus 4m plus 6. And what we can do is take out a 2 as a common factor. So we have 2 multiplied by 2m plus 1 multiplied by 2m squared plus 2m plus 3. So we see that 2 is a factor, so it's even because it's got 2 as a factor. And because we've shown that n multiplied by n squared plus 5 is even for both odd numbers and even numbers, we can therefore conclude n multiplied by n squared plus 5 is even for all natural numbers. Question number 12. The function f is defined by f of x equals e to the 3x over 4x squared plus k, where k is a positive constant. For part A, we have to show that f dash of x is equal to 12x squared minus 8x plus 3k multiplied by g of x, where g of x is a function to be found. So, for part A, we know what f of x is, and because we are differentiating a fraction where the numerator and the denominator are both functions of x, we can use the quotient rule. U is equal to 3 to the x. U dash is then equal to 3e to the 3x. V is equal to 4x squared plus k. V dash is equal to 8x. And what we need to do is find f dash of x. F dash of x is equal to v 4x squared plus k multiplied by u dash 3e to the 3x, subtract u, which is e to the 3x multiplied by v dash, which is 8x, and then we divide this by v squared, so we divide this by 4x squared plus k squared. So, if we work this out, well, what we can do is factorize out an e to the 3x from both terms in the numerator, and then we are left with 3 multiplied by 4x squared plus k, subtract 8x, and then we divide this by 4x squared plus k all squared. So we have e to the 3x multiplied by, well, here I've got 3 times by 4x squared, which is 12x squared, 3 times by k and then minus 8x, we've got minus 8x plus 3k. And then we will divide this by 4x squared plus k all squared. And so what we have then is 12x squared minus 8x plus 3k multiplied by e to the 3x divided by 4x squared plus k. This is g of x. So g of x then is this function here, e to the 3x over 4x squared plus k squared. And so therefore f dash of x is equal to 12x squared minus 8x plus 3k multiplied by g of x. Now for part B, given that the curve with equation y equals f of x has at least one stationary point, we have to find the range of possible values of k. Well, because we are considering stationary points, we need to set f dash of x equal to 0 for part B. So for part B, if we have f dash of x equaling 0, we have 12x squared minus 8x plus 3k multiplied by g of x equaling 0. So, as g of x cannot equal 0, and that's because we have e to the 3x involved, this would imply we are solving the equation 12x squared minus 8x plus 3k equals 0. And what we know from the question is we've got at least one stationary point, which means we have real solutions to this equation. So, in other words, if we were to use the discriminant b squared minus 4ac, and if we set this greater or equal to 0, because we have at least one stationary point, we have minus 8 squared minus 4 times by 12 times by 3k being greater or equal to 0. So we have 64 minus 144k is greater or equal to 0. So therefore k is less than or equal to 4/9. And therefore the range of values of k, we've got 0, which is less than k, which is less than or equal to 4/9, because we know k is a positive integer. So here are the range of values of k. Question number 13. Relative to a fixed origin O, the point A has position vector 4i minus 3j plus 5k. The point B has position vector 4j plus 6k. The point C has position vector minus 16i plus pj plus 10k, where p is a constant. Given that A, B and C lie on a straight line, what we have to do is find the value of p. Now for part A, what we can do is find out A, B and C as column vectors for now. A as a column vector, we've got 4, -3, 5. B, which is 0, 4, 6. And C, which is -16, P, 10. And we know that A, B and C lie on a straight line. Then if A, B and C lie on a straight line, what we can say from this then is some constant lambda times the vector BA is equal to the vector CA. And to demonstrate this, let's draw a diagram. So if here I've got the origin, then somewhere here I've got A, and then I know that I've got a straight line. I know that B lies somewhere on this straight line and C lies somewhere on this straight line. And what I am saying here is BA is a fraction of CA. So, if that's the case then if we were to find out what BA is and then CA, we can use this idea to help us find the value of P. So if we were to find the vector BA, that's equal to OA, which is this vector here, and then I subtract from this the vector B, which is this vector here. And working this out then, the vector BA is equal to 4 minus 7 minus 1. We can now find out the vector CA. So the vector CA, that will equal the vector OA subtract the vector OC, which is that vector here, and if we work out what this is, 4 subtract -16 is 20, -3 subtract P, I've got -3 take away P, 5 take away 10, that's -5, which is what we have here. And so, what we can say then, since lambda times BA is equal to CA, we've got lambda times by BA, which is equal to CA, as we see here. And so what we can do is find out the value of lambda by inspection. And if we take a look at the k components, I've got negative lambda equaling negative 5. So lambda is equal to 5. And now if I take a look at the j component, then I've got negative 7 lambda equals negative 3 subtract p. I've got negative 7 multiplied by 5 equals negative 3 subtract p. And so we've got negative 35 equals negative 3 subtract p. P then is equal to positive 32. And knowing what p is, we can therefore conclude the vector OC will equal negative 16, 32, 10. Now, for part B, the line segment OB is extended to a point D so that CD is parallel to OA. You have to find the magnitude of OD, writing your answer as a fully simplified third. So, for part D, the best way to approach this question is to draw a diagram. So we've got this original diagram here, and what's happening is OB is extended to a point, and the result of that is we get to some vector D. So if I extend this line here, then what's happening in this question is we've got the point D over here somewhere, and this point D is what we need to find. So OB is extended to OD, and the result of that is OA is parallel to CD. So that's what the question is referring to. And what we need to do is find out what D is. So if we extend OB to OD, OBD then is a straight line. And if OBD is a straight line, that means that OD is equal to some constant mu multiplied by OB. So we have mu multiplied by the vector OB, and the vector OB is 0, 4, 6. So we know what OD is. Now, can we get from O to D in any other way? Well, before we do anything else, if we consider this statement that CD is parallel to OA, then if CD is parallel to OA, then CD will equal some constant, we'll call it T, multiplied by OA. So now we know what CD is in terms of OA. Well, if we think about it, well, let's just highlight this. CD is equal to some constant multiplied by OA. What we can do is find out what OD is from the diagram. So from the diagram, I can go from O to D via C. From the diagram then, OD will equal OC plus CD. So I've got OD equaling OC. Now I know what OC is. I worked that out over here. That's minus 16, 32, 10 as a column vector, plus the vector CD. Now CD is T multiplied by OA. So I've got T multiplied by the vector OA, which is this vector here. And so, because I know that OD is equal to this result here, which is also equal to this result here, I can find mu and T, and from that I can find out what OD is. So therefore, I've got OD, which I've just found to be this vector here, and that will equal this over here. They are both equal to OD. And so we can compare components to find out what mu and T are. Now if I take a look at the J component, I've got 4 mu equals 32 subtract 3t. So 4 mu is plus 3t equals 32. And if I take a look at the K component, we've got 6 mu equals 10 plus 5t. So I've got 6 mu subtract 5t equals 10. If I call this equation 1 and this equation 2, then I can solve 1 and 2 simultaneously to find out what mu and t are. So from our calculator, if we go to the simultaneous equations solver, we've got 4, 3 and 32, 6, minus 5 and 10. So it turns out then mu is equal to 5, t equals 4. And so therefore, the vector OD is equal to mu, which is 5, multiplied by 0.46. And so OD then is equal to 0 20, 30. And so therefore, the magnitude of OD that will equal (20 squared plus 30 squared square rooted), and working this out, it turns out we get 10 times the square root of 13. Question number 14 for part A, we have to express 3 over 2x minus 1 times x plus 1 in partial fractions. So for part A, we have 3 over 2x minus 1 times x plus 1, which we need to express into partial fractions. So what this is equivalent to, we have a over 2x minus 1 plus b over x plus 1. And if I multiply through by 2x minus 1 times x plus 1, we have 3 being equivalent to a multiplied by x plus 1 plus b times by 2x minus 1. So when x is minus 1, we have 3 equals. Now here I have minus 1 minus another 1, so that's minus 3, and multiplying that by b, we have minus 3b. So b is equal to negative 1. And if I substitute in x equals 1/2, then we have 3 equals a times by 1/2 plus 1. So that will be 3 over 2a. And so therefore, a will equal 2. And knowing the values of a and b, we can therefore conclude that 3 over 2x minus 1 times x plus 1 is equivalent to 2 over 2x minus 1 minus 1 over x plus 1. Now for part B, when chemical A and chemical B are mixed, oxygen is produced. A scientist mixed these two chemicals and measured the total volume of oxygen produced over a period of time. The total volume of oxygen produced, v meter cubed, t hours after the chemicals were mixed, is modelled by the differential equation dv over dt equals 3v over 2t minus 1 times t plus 1, where v is greater or equal to 0 and t is greater or equal to k, and k is a constant. Given that exactly 2 hours after the chemicals were mixed, a total volume of 3 meters cubed of oxygen had been produced. With this, we have to solve the differential equation to show v equals 3 multiplied by 2t minus 1 over t plus 1. So, for part B of the question, we have dv over dt. This will equal 3v over 2t minus 1 multiplied by t plus 1. And we know that v is greater or equal to 0 and t is greater or equal than k. Now we can separate the variables, everything with a v on one side, everything that's not a v on the other side. So we have 1 over v dv equaling 3 over 2t minus 1 multiplied by t plus 1 dt. And what we need to do is integrate. So if I integrate 1 over v with respect to v, we end up with the natural log of the mod of v. Well, before that, what we can do on the right hand side is use our partial fractions result. With our partial fractions, we can rewrite 3 over 2t minus 1 times t plus 1 as 2 over 2t minus 1 over t plus 1 dt. So we've got the natural log of v equaling, well, if I integrate 2 over 2t minus 1, that's the same as the natural log of the mod of 2t minus 1. And if I integrate 1 over t plus 1, I end up with the natural log of t plus 1. And then I need to add on a constant of integration. We'll call it c for now. So we have the natural log of the mod of v equaling, now on the right hand side I can combine the logarithms using the subtraction law. So I have 2t minus 1 divided by t plus 1 modded plus c. Now I was given a condition that when t is 2, then v is equal to 3. So if I use that condition, t is 2, v is 3, then we have the natural log of 3 equaling the natural log of, well, here I've got 6 minus 1, rather I've got 4 minus 1, which is 3, and then here I've got 2 plus 1, which is 3. And then I add on a constant of integration plus c. So I've got the natural log of 3 equaling the natural log of 1 plus c. The natural log of 1 is 0, in which case I can conclude from here c is equal to the natural log of 3. And knowing what c is, we can therefore conclude that the natural log of v equals the natural log of 2t minus 1 over t plus 1 plus the natural log of 3. And now, using the addition law of logs on the right hand side, well, we've got the natural log of v on the left hand side, but on the right hand side we would have the natural log of the mod of 3 multiplied by 2t minus 1 over t plus 1. And that is the result which we wanted to show. And now if we antilog both sides, v then is equal to 3 multiplied by 2t minus 1 over t plus 1. Now for part C, the scientists noticed that there was a time delay between the chemicals being mixed and oxygen being produced, and there was a limit to the total volume of oxygen produced. We have to deduce from the model the time delay giving an answer in minutes, and then the limit giving an answer in meters cubed. So, for the first part of part C, if there's a time delay to the oxygen being produced, that would imply V was equal to 0. No oxygen has been produced. So we've got 3 multiplied by 2t minus 1 over t plus 1 equaling 0. 2t minus 1 is 0. So then t is equal to 1/2. That's in hours. And so therefore, we have 30 minutes. Now we need to find out the limit. What's happening over here is, if there's a limit to the total volume of oxygen produced, what we're saying essentially is, what happens as T gets very large? And as T gets very large, the amount of oxygen we have, V, will be limited. Now, to approach this question, let's rewrite V. Let's rewrite V by multiplying the 3 into the bracket 2t minus 1. So I would have 6t minus 3 divided by t plus 1. Now, what we want to do is see what happens as t gets very large. Now, before we do that, we can rewrite V again as 6 subtract 3 over t over 1 plus 1 over t. And now we can see what happens when t tends towards infinity, as t gets really, really large. When t gets really, really large, V would tend towards 6 minus 0 over 1 plus 0, which is just 6. And so therefore, we can conclude that the limit is 6 meters cubed. Question number 15. Given that the first 3 terms of a geometric series are 12 cos theta, 5 plus 2 sin theta, and 6 tan theta, we have to show that for part A, 4 sin squared theta minus 52 sin theta plus 25 equals 0. Now, if we have a geometric series, that means to go from one term to the next term, we multiply by r. And so, what we can see then, for part A, to find out what r is, we need to divide consecutive terms by each other. So, I've got the 5 plus 2 sin theta divided by 12 cos theta, that will equal 6 tan theta divided by 5 plus 2 sin theta. And what we need to do is find out a quadratic equation from this. So, if we cross multiply we have 5 plus 2 sine theta multiplied by 5 plus 2 sine theta, so that's 5 plus 2 sine theta squared. That will equal 6 tan theta multiplied by 12 cos theta. So, on the left hand side, we have 5 plus 2 sine theta all squared, and on the right hand side, 6 times by 12 is 72, and tan theta we can rewrite as sine theta over cos theta, and then we are multiplying this by cos theta. It's as though these cos thetas simplify to 1. So if I expand on the left hand side, we have 25 plus 20 sine theta plus 4 sine squared theta, and that's equal to 72 sine theta. And if we take everything over to one side, we can therefore conclude that 4 sine squared theta subtract 52 sine theta plus 25 equals 0. And now for part B, given that theta is obtuse and it's measured in radians, we have to solve the equation in part A to find the exact value of theta. Well, for part B, we can factorize this quadratic equation, leaving us with 2 sine theta subtract 25 multiplied by 2 sine theta subtract 1 equals 0. Now, if we have 2 sine theta minus 25 equals 0, that would imply sine theta equals 25 over 2. But we can't have this because sine theta can only be in between minus 1 and 1. And so therefore, we have 2 sine theta minus 1 equaling 0, in which case sine theta is equal to 1/2 only. And if that's the case, we've got theta either equaling, well, I've got the inverse sine of 1/2, which is pi over 6, or I've got my obtuse angle, pi subtract this, which is 5 pi over 6. These are my values of theta, and as theta is obtuse, we can therefore conclude that theta is pi over 6 only. Rather, theta is 5 pi over 6 only. Now, for part C, we have to show that the sum to infinity of the series can be expressed in the form k multiplied by 1 minus root 3, where k is a constant to be found. Now, from the formula book, the sum to infinity is given by a over 1 minus r for the mod of r being less than 1. So what we need to find is r and our first term. So, to find out what our first term, a, is, well, we know from the question that's given by 12 cos theta. And with theta equaling 5 pi over 6, we have 12 times by the cosine of 5 pi over 6. So working this out, we get minus 6 root 3. So this is the first term. The common ratio r, that's equal to, well, if we use what we had here, but replacing the theta with the value 5 pi over 6, then what we would have then is r equaling, well here, I've got 5 plus 2 times by the sine of 5 pi over 6 over this, which is negative root 3 over 3. So now that we know what a is and we know what r is, we can therefore conclude that the sum to infinity is equal to a minus 6 root 3 over 1 minus root 3 over 3. And we need to show that this is in a particular form. So if we multiply through by 3, then we have minus 18 times the square root of 3 over 3 plus root 3. And what we have to do now is multiply both the top and bottom by the conjugate of the bottom. So I've got 3 minus root 3 over 3 minus root 3. It's as though we are multiplying by 1. So if I work this out, we have minus 54 root 3 plus 54 over, well, on the bottom we've got a difference of 2 squares, so we've got 9 subtract 3. So 9 subtract 3 is 6. So what we end up with is minus 54 root 3 over 6, which is minus 9 root 3, and then 54 divided by 6 is 9. And if I factorize out a 9, I've got 9 multiplied by 1 minus root 3, in which case I can see k is equal to 9. Question number 16. Figure 6 shows a sketch of the curve C with parametric equations 2 tan t plus 1 equals x and 2 sec squared t plus 3 equals y, where t is in between minus pi over 4 and pi over 3. The line L is the normal to C at the point P, where t equals pi over 4, and using parametric differentiation we have to show that an equation for L is y equals minus 1/2 x plus 17 over 2. So for part A, if we know that x is equal to 2 multiplied by tan t plus 1, we'll just call this equation 1 for a moment, then differentiating with respect to t, dx over dt will equal, well, if I differentiate tan, then what I end up with is sec squared. So what I end up with here is 2 times by sec squared t. And if I know that y is equal to 2 sec squared t plus 3, I'm going to rewrite that as 2 times by sec t squared plus 3 and call this equation 2. Then to find out what dy over dt is, I can differentiate using the chain rule. So I've got 2 times by the 2, which is 4, and then I have sec t raised to the power of 1, and then I multiply this by the differential of the bracket, and if I differentiate sec, we end up with sec t tan t. So I need to multiply this by sec t times by tan t. And if we tidy this up, we end up with 4 sec squared t times by tan t. And so to find out what dy over dx is, that is the same as dy over dt divided by dx over dt. So dy over dt, that is 4 sec squared t tan t, and dx over dt, that is 2 sec squared t. And the 4 over 2 gives 2. Sec squared divided by sec squared simplifies to 1. And then we just have the tan t with it. Now we need to find out the equation of the normal when t equals pi over 4. So when t equals pi over 4, we can find out what x is, what y is, and what dy over dx is, and then the gradient of the normal. So x is equal to 2 times by the tan of pi over 4 plus 1. So it turns out that's 3. Y is equal to 2 sec squared of pi over 4 plus 3. Now, what is sec squared? Well, sec is the same as 1 over cos, so I've got 1 over the cosine of pi over 4, and then I square this and multiply it by 2, and then I add 3 to it, so it turns out y is equal to 7. And dy over dx will equal 2 times by the tangent of pi over 4, which is 2. Now this 2 here would represent the gradient of the normal. And so therefore, rather it represents the gradient of the tangent. So therefore the gradient of the normal, that will be the negative reciprocal of 2, which is minus 1/2. So I've got the gradient of the normal equaling negative 1/2. So now I have enough information to find out what the equation of the normal is. So therefore, for the equation of the normal, we have y minus y1, so that's y minus 7, equals minus 1/2, the gradient, times by x minus x1, so that's x minus 3. So therefore, the line L that has equation y equals 1/2 x plus 17/2. So that's what L is. Now for part B, we have to show that all points on C satisfy the equation y equals 1/2 multiplied by x minus 1 all squared plus 5. Well, if I take a look at equation 1 and 2, I will label them over here. We want y equals a function of x. Now, to do this, what I can do is recognize that sec squared is the same as 1 plus tan squared, and I can somehow get a tan squared from equation 1. So, for part B, from equation 1, I can see that the tangent of t is equal to x minus 1 over 2. And so therefore, tan squared t is equal to x minus 1 over 2 squared. And from equation 2, where we've got y equals 2 times sec squared t plus 3, I can replace the sec squared with 1 plus tan squared. So I would have y equals 2 multiplied by 1 plus tan squared t plus 3. So we have y equals 2 tan squared t, and then here I've got 2 plus 3, which is 5. So let's call this equation 3, and let's call this equation 4. What I can do is substitute in equation 3 into equation 4. So I would have y equals 2 times by tan squared. Now we know what tan squared is. That's x minus 1 over 2 squared plus the extra 5. And so 2 times by 1 over 2 squared, that's a half. So I have y equals 1/2 times x minus 1 all squared plus the 5. And that's exactly what I wanted to show. We'll call this equation 5 for now. And now for part C of the question, the straight line with equation y equals minus 1/2 x plus k, where k is a constant, intersects C at 2 distinct points. We have to find the range of possible values for k. Now, before we do anything else, what we can do is find out the domain of this equation. We can find the domain of the Cartesian equation by replacing the t's with the minus pi over 4 and the pi over 3. And we can use equation 1 for this. So, for part C, the domain of equation 5, which is the Cartesian equation, we have 2 times by the tangent of minus pi over 4 plus 1, which is less than or equal to x, which is less than 2 times by the tangent of pi over 3 plus 1. So the inverse tangent of minus pi over 4 or it's the tangent of pi over 4 minus pi over 4 plus 1, rather, over 2 times by this, plus 1. So that's minus 1, which is less than or equal to x, which is less than or equal to, now here I've got 2 times by the tangent of pi over 3 plus 1. So that is 1 plus 2 root 3. So I've got my x domains. So if I go back to my diagram, what we have here is minus 1, and what we have here is x equals 1 plus 2 root 3. Now, what we can do in this question, well, we've got equation 5, which is our Cartesian equation of C, and then we've got this straight line, we'll call it equation 6, and equation 5 and equation 6 intersect at 2 distinct points, and we have to find the range of possible values for k. Now, here you can see we've got our straight line, y equals minus 1/2 x plus k, and here we've got our equation C. That's y equals 1/2 times x minus 1 all squared plus 5, between minus 1 and 1 plus 2 root 3. And if I increase the value of k, we can see that in between two particular values, it would intersect twice. Now, between somewhere here and somewhere here, they intersect twice. But anything beyond this, they intersect only once. So, we want them to intersect twice, which means, if I zoom in, I want the discriminant to be greater or equal to 0, and beyond this point over here is where they would intersect only once, as we see here. So, let's first of all set equation 5 and 6 equal to each other. What we have is 1/2 times x minus 1 squared plus the 5 equals minus 1/2 x plus k. And if I multiply through by 2, I've got x minus 1 squared plus 10 equals minus x plus 2k. Expand the brackets. I've got x squared, subtract 2x plus 1 plus 10 equals minus x plus 2k. And if I take everything over to one side, that means I would have x squared minus x plus 11 minus 2k equals 0. Now, why is this important? Because now what I can do is use the discriminant to find out the range of values of k. And going back to our diagram, around a value of here is what we want k to be greater than. So, if we use the discriminant b squared minus 4ac being greater than 0, and the reason it's greater than 0, not greater or equal to 0, is because if it was equal to 0, it would only intersect once. So I've got minus 1 squared minus 4 AC being greater than 0. So I've got here 1 minus 44, so that's minus 43. And then I've got minus 4 times by minus 2k, so that's positive 8k. Minus 43 is greater than 0, in which case I can see k is greater than 43 over 8. So that's one of the limits. Now if I go back to my diagram, I can find out the value of k for which I would have two roots. So if I go back to my animation, around this value I can find out what the corresponding k value is. And I can do that by substituting x equals minus 1, which comes from here. So if I substitute in x equals minus 1 into here, I've got minus 1 squared minus minus 1 plus 11 minus 2k equals 0. And so therefore 2k is 13, k is equal to 13 over 2. And so for values less than or equal to 13 over 2 but greater than 43 over 8 is the range of values I want for us to have two distinct points. And so therefore the range of values for k then would be 43 over 8, which is less than k, which is less than or equal to 13 over 2.